Class, in this video, we're going to be learning how to find the equation of a straight line. In order for us to find the equation of a straight line, we need to be given two coordinates that are found on the straight line, and so that way we can represent it in the slope-intercept form. Please remember that the slope-intercept form can be given by this equation over here, where y is equal to mx plus c, but alternatively, it could also be written as y is equal to a plus bx. Remember that both of these equations represent the same thing, but they're just represented in a different way using different letters, okay? But because the textbook uses this formula over here, I'm going to be representing my equations in the y equals a plus bx general formula. The difficulty of finding the equation of a straight line will actually vary depending on what two coordinates are given to us by the graph. So for questions that already give us what the y-intercept is, I give this as a 1-star rating because you really need to do only one line of working out in order for you to get the equation of the straight line. In contrast, when both of the coordinates that are given to you do not tell you what the y-intercept value is, you're going to need to do a bit more working out. So in this case over here, I've given this as a 2-star rating in terms of difficulty. So let's look at the very first example where one of the coordinates is equal to the y-intercept. What you're going to be doing is you're going to be following these 3 steps over here in order to get the equation. So step 1 says, state what is our y-intercept. Now in this case over here, by reading off the graph, we can clearly see that the y-intercept is going to be equal to -3. So I'm going to write a is equal to -3. Step 2 says we need to find the gradient. So in order to find the gradient, we need to know 2 coordinates. I've got the first coordinate already, which is our y-intercept. The second coordinate that I'm going to be choosing that's on the straight line is 1, 1. And to therefore get the gradient, I'm going to label the coordinates as x1, y1, x2, y2. And in this case over here, y2 is equal to 1. So 1 minus -3 over 1 minus 0. Simplify this. So therefore it becomes 4 in this case. And now all we need to do is substitute our answers for step 1 and step 2 back into this equation over here. So our answer is going to be y is equal to -3 plus 4x. I'm hoping that this is really straightforward for you guys. So what I want you to do now is I want you to please have a go at answering this question, and we'll go through the answers in a minute. If you have done this question correctly, you should have stated that the y-intercept value is going to be equal to 2. In order for me to find out my b value, the gradient, I'm going to identify another coordinate on a straight line. So I'm going to be using this value over here, but you may have used a different value. So after I've done this, I'm going to label as x1, y1, x2, y2 to find the gradient. So it's going to be 0 minus 2 over 4 minus 0. Simplify this. This is equivalent to -0.5 or -0.5. And lastly, I just need to substitute the values back into the general equation. So therefore, my answer is going to be y is equal to 2 minus 0.5x. So we've now just finished looking at the very first type of examples where one of the coordinates is always going to be equal to the y-intercept. Let's look at the second example where none of the coordinates are the y-intercepts. When you get questions posed in this particular format over here, instead of finding what is our y-intercept first, which is what we've done over here, we're actually going to be finding out what is our gradient first. And after you find the gradient, then we can find out our y-intercept, and then we can write it in the rule. So let's use an example over here. What I'll do first is I will label the coordinates as x1, y1, x2, y2, like so. After that, I'll find out what is a gradient. So in this case over here, it'll be -5 minus 5 over 3 minus -2. Just be careful of the negative signs. So when you simplify this, your gradient is going to be equal to -2. So now that I've got my gradient or my b value, I need to solve for my a value. And this is achieved by substituting one of the coordinates, so either this coordinate or this coordinate over here, into this equation. So what I'll do is I'll substitute the most easiest one, the one with the lower values generally. So if I substitute that in, wherever y is, I'll replace that with the number 5, and wherever x is, I'll replace that with -2. Now I just need to simplify this. So -2 multiplied by -2 is equal to +4. Get a by itself, so let's move the 4 to the other side. We'll subtract 4 from both sides, and in doing so, a is going to be equal to 1, and therefore your equation is equal to y is equal to 1 minus 2x. I'd like you to now have a go with answering this question, and we'll go through the answers again in a minute. So what I'll do for this question over here is I'm going to choose two coordinates. So you could choose any two coordinates, but I've chosen to use 2, 2 as well as 3, 6. I'll label them as x1, y1, x2, y2 to find the gradient value. The gradient in this case over here, despite what values you've used, should always be equal to 4 in this case, positive 4. And after I found out what is my b value, my gradient, I'm going to solve for my a value by substituting one of the coordinates in. I'm going to substitute 2, 2. And if you've done this successfully, you should have got your a value as -6. So that's my y-intercept value. So therefore, your equation should be y is equal to -6 plus 4x. To get further practice, I'd like you to please complete questions 1 and 2 from exercise 6D. So from exercise 6D, notice that the y-intercept values have already been given to you. So these are like the one-step types of equations. Whereas questions from exercise 6A, notice where none of the y-intercepts are given. So you're going to need to do a bit more working out. This is the end of the video. Thank you for watching, and I'll see you guys again in the next video. Bye.